All right, I believe we have everything ready to get started. And so I'd like to start by welcoming everyone to another webinar by JScrambler, this time exploring the topic of mitigating Magecart web skimmers with a behavior-based solution. With this in mind, today we will be looking at this security threat and key business problem of web skimmers, commonly known as Magecart. We will dig into the current status of these attacks, the techniques used, and which strategies help minimize this risk. Before we get started, I just want to remind you that you'll find a question box right there on your screen that you can use to place your questions. We'll do the Q&A at the end of the webinar, but feel free, of course, to use the question box at any time. And don't be afraid of getting technical, because both our speakers today will certainly be able to help out. Moving forward, I want to present our speakers for today. Joining us, we have Pedro Fortuna, who is of course the CTO and co-founder of JScrambler, as well as Karin Azevedo, which is a pre-sales engineer also at JScrambler. So I'll go right ahead and move the floor over to Karin for her analysis of the current panorama of web skimming attacks. Thanks for joining us, Karin, and feel free to take it away.
Hello, everyone. Hi, Felipe. Thank you for the introduction, and thank you guys for joining us today. Well, my goal today is just to give a clear picture of Magecart web skimming attacks so that we can then explore different approaches to mitigate this threat. So first, clear explanation, and then the approaches. So I thought the best way to get started was with some headlines, because most people first hear about Magecart because of one of these stories. A huge enterprise that fell victim to a massive data breach and later on received the biggest GDPR fine ever. But the British Airways breach wasn't the peak for Magecart. Just recently, we've seen these cybercriminal groups breach companies like Claire's, Intersport, Fitness Depot, and Tupperware. And just a couple of weeks ago, we learned about 8 US cities that also were breached by Magecart. These high-profile web skimming attacks are getting more frequent, and the data shows us precisely this. According to RiskIQ, Magecart attacks have risen by 20% during the pandemic, a time where we also saw a huge increase in online shopping. In the US, online shopping grew by around 49% in April alone, and certainly this volume has presented a unique opportunity for this type of attacks. Other research shows that there have been 2 million web skimming attacks so far, with 20,000 compromised websites. But probably the most important statistic is this last one. A web skimming attack remains active on average for 22 days before being detected and removed. We have seen some cases where 6 or more months go by without companies being aware that their websites are infected. That's huge. So another interesting fact among these high-profile attacks is the average size of the affected companies. Attackers are successfully breaching multiple billion-dollar companies, and in June alone we saw several examples of this, which I have presented before. The outcome of these web skimming attacks will always vary depending on the dimension of the breach, but most frequently they have a significant negative impact on the business, of course. One of the first problems after a Magecart attack is the breach of compliance with strict data privacy regulations, such as GDPR and CCP, for example. The British Airways breach resulted in a $230 million fine and showed that web skimmers are a very real threat to the privacy and security of user data. Then we also have the payment card industry data security standard. Every merchant that accepts credit card payment must be in compliance with PCI DSS, and falling victim to a Magecart attack also represents a breach in compliance. Still in litigation, we have seen some of these high-profile attacks being followed by a massive lawsuit of hundreds of millions of dollars, as affected customers, of course, look for restitution for the breach of their data. And companies affected by these data breaches are frequently received with backlash from customers and, of course, instant loss of trust due to negative publicity. While the actual impact in the business is difficult to measure, it is likely to do a long-lasting damage in lost sales. As these skimming attacks gain notoriety in recent months, we have seen specific alerts from the PCI Council warning about the growth in web skimming during the pandemic. And even the FBI has launched an alert back in November, if I'm not mistaken, seeking to raise awareness about these attacks and the threat they pose to online merchants. But how do Magecart attacks typically operate? This image here by RiskIQ shows the typical scenario of a web skimming attack. Here, as you can see, you have multiple cybercriminal groups that inject the malicious skimmer into the web page of an e-commerce store, either by directly gaining access to their target's website or by injecting the malicious code through a third party. When an end user submits the payment form in an infected website, the malicious code grabs this information and sends it to the drop server. Then, these credit cards are sold in dark web markets or used to reship products overseas. It may seem strange that such a complex operation is capable of flying under the radar of such well-established enterprises. But that's the main ingredient to Magecart's success, their ability to remain undetected. And this ability mostly comes from the attacker taking advantage of a security blind spot that most companies have. The typical website application contains a huge mashup of client-side code, frameworks and libraries that are used during the development of these platforms contains dozens of pieces of third-party code, creating such a long chain of code dependencies that companies don't really have a way to know what code they are effectively running. What makes matters worse is the fact that a log of sensitive data passes through the client side at some point in time, meaning that this data will be at risk. More traditional security approaches, such as server-side security or even firewall, they do not contemplate these client-side security weaknesses. And even browser security mechanisms are falling short to shield websites against possible attacks like web skimming. But let me go ahead and focus on the more dangerous approach to Magecart attacks, those that originate from third parties. Like I mentioned earlier, this approach doesn't require breaching the first-party server. So what we have here on the left is a typical website containing HTML and JavaScript. So let's assume that this is our own e-commerce platform, okay? Apart from our own code, we also have some external code like iframes or scripts. An example of a script could be a live chat widget, which is quite common in e-commerce platforms. But here on the right side, we have the actual attack. Our live chat widget uses a full JS file that contains basically the whole logic. But that code is itself dependent on a third-party code. In this case, we have a bar.js script that is part of the source code of our full JS live chat. In this attack scenario here, someone gained access to the bar.js repository and injected malicious code containing a web skimmer. Because this change can happen without any visibility from the provider of the chat widget, the malicious code will silently ship to all the users of this live chat, including, of course, our e-commerce platform. These types of skimmers typically perform multiple regex checks to be able to infect as many payment forms as possible. I'll show you an example of this in just a minute. But now, let's look at what happens when one of our customers fills out a payment form. The malicious code will capture the submitted credit card data and send it to the attacker's drop server, in this case, coolestfonts.com. But attackers often go even further. So instead of sending the data out directly to the drop server, they first send it to the legitimate domain of the live chat provider, for example, and only then relay it to the attacker's drop server. This two-step process makes it even harder for us to know that something is wrong. Our website is running the code of a live chat widget, right? Like it always has. And then it is sending some data to the website of this provider, which is not suspicious at all. Now let's look at the real example of a skimmer. Here we have the skimmer used in the Inventa breach, which happened in 2018. As we can see, this code is highly obfuscated, a technique that attackers use to increase their ability to fly under the radar. After a complex effort to deobfuscating this code, we find the second version. Now we can actually understand what the skimmer did. First, starting from the bottom, the skimmer contains some logic with regex checks to confirm that it is running in a payment page. And that's why we can see the terms order and checkout here. Then it iterates all buttons so that it can compromise the click event, adding event listeners to the click of those elements. Then it will get any element that is a form. And the same way that it compromises the click, it compromises the forms, using the same function to poison the submit event. Finally, after the attackers have been able to collect all data, they send a new outbound request to their drop server containing all this information, including the credit card details. In the eye of the end user, the payment will be processed normally, without any indication that something went wrong. The skimmer also contains additional logic to run this logic again in set intervals. This works like a fail-safe logic kind of thing in case a skimmer hadn't loaded correctly in the past attempt. So basically, it will keep on trying to run the attack until it's successful. So this might seem like a pretty sophisticated skimmer, but as I will explain later, the most recent skimmers have even more advanced logic that makes them much harder to detect. And so it's not really surprising that attackers are still winning this game, right? They don't need to breach a very secure server of their target. They can just go after the weakly secured server of their third or fourth party providers. And you may have noticed a big difference between this approach and the typical first party server breach. So in a first party breach, attackers can grab all the data of thousands of users at once, just like this. But web skimming is very different because it takes time. Credit card details are exfiltrated in each user session, so with enough time, attackers can infect thousands of user sessions and greatly increase their payout. This was precisely what happened to British Airways. In 15 days' time, attackers stole over 380,000 credit cards. In other words, 18 credit cards per minute. Which means that we can basically summarize any web skimming attack with this formula, taking special attention to the count of our time in minutes and not days. Because if the average Magecart attack stays active for 22 days before being detected, then we're talking about over 30,000 minutes. And each minute that goes by with an undetected skimmer means a bigger and bigger problem to the business. All of this leads us to the billion-dollar question. So how can companies turn the tide? Well, as we've seen, this doesn't look great for companies, right? So the last generation of web skimmers are using very advanced techniques to avoid detection. Besides using obfuscation techniques to conceal their malicious code, they are actually using defense mechanisms to avoid being detected at all by bots, rendering many detection approaches useless. But the bottom line is fairly straightforward. Looking back at our formula, what companies need to do to effectively mitigate Magecart is to bring this second portion down to zero. In other words, companies need to detect and stop Magecart schemers in real time in order to avoid a breach. Okay, I know this all sounds great, but which specific strategies can businesses use to shield themselves against Magecart? Well, let's start by looking at some of the ones that are more frequently associated with Magecart. One of these is sub-resource integrity, or SRI for short. This approach allows you to add a parameter to a loaded script containing a hash which corresponds to the checksum of the original file. So if the tiniest change occurs to the script, this checksum will be different and SRI will prevent the script from loading, just like that. At first glance, this seems like an excellent approach to prevent Magecart attacks that originate from third party like the example we saw before. However, there are some shortcomings to this approach. First, SRI is basically locking you to the specific version of these scripts. Any update will require changing this script tag and will typically mean that you will be dragging behind on versions. And in cases where you are using SRI for self-hosted files, there's also the case of attackers being able to modify the file system and removing the tag, the entire tag altogether. A second popular approach is content security policy. So what CSP does is let you define which external sources your website can connect to. You whitelist the sources you trust, and every other connection will basically be blocked. And you might already know CSP because it's frequently used to prevent cross-site scripting attacks. What is very interesting about CSP is that it can disable inline scripts and unsafe eval. In theory, this could help us deal with some types of web skimming attacks. But there is a big problem with CSP. Some researchers have found out that 94% of first-generation CSPs can be bypassed. And even if we get past that, there's not much that CSP can do when it comes to third-party web skimming attacks. So let me go back to my example to show you what it means. Okay, so CSP works by blocking connections that are not whitelisted. But in this example, the skimmers comes from a whitelisting domain. For example, a live chat provider. This means that CSP won't really block this connection. But what about blocking the connection when attackers send the data out? Well, when I showed this earlier, I mentioned that the attacker can find a way around this. They can first send the data to the legitimate server of the provider before really sending it out to their drop server. So again, CSP can't really do anything here when this happens. So CSP isn't really the right tool to prevent web skimming. There are just too many ways to exfiltrate data. Plus, CSP headers can also be stripped out by browser extensions. Okay, now let's move on to some lesser known approaches. And first, we have domain sinkholing. I won't really get into much detail about this approach because it's fairly complex, but it basically uses custom detection policies that look for code that appears to be skimming data. When suspicious code is detected, it triggers the domain sinkholing process, where it diverts the outbound request containing the exfiltrated data. So instead of sending the data to the drop server, it sends it out into a void or a sinkhole. But again, There are several drawbacks to this approach. And probably the most obvious one is that it is signature based. This is a big deal because we know that when the skimmer is obfuscated, it can break out of signatures. And another problem with signature based is that we keep seeing new approaches to web skimming attacks. So these new attacks won't be detected by these types of solutions. Let me now move on to another type of approach which relates to the usage of JavaScript virtualization. This one is one of the most promising approaches to effectively tackle web skimmers. So it isolates every piece of third-party code inside an iframe and filters events based on a static whitelist. But the problem of JavaScript virtualization is not its raw capability of mitigating Magecart attacks. Even if you manage to get it working right, which is very tricky, I must say, it can very easily introduce a new race condition and start breaking things, potentially ruining the experience of your users. And there is also another detail that we must consider. Because the logic of this solution will have to run on the client side, it will be exposed to tamper attempts and bypass. So the solution must be hardened with resilient code protection. So what does all of this tell us? Well, first, browser security by itself is surely not enough. There are all these different techniques that have many strengths to them. And so we should try maybe to leverage a combination of sandboxing, poisoning detection, and down tampering detection. It must be capable of doing both static and dynamic JavaScript analysis, and even use the best possible deobfuscation techniques to uncover obfuscated skimmers. Finally, it must include resilient code protection to prevent tampering attempts. And so you may have noticed a changing approach here. Instead of trying to prevent the infection itself, we're talking about changing the mindset. And we like to call this approach behavior-based mitigation. But well, for more on that, I will hand the floor over to Pedro Fortuna.
Thank you, Karen, and thanks everyone for joining us today. As a security researcher, I've been actively engaged in understanding how these attacks work. But more important than that, I've been working on technical solutions that can help companies mitigate this type of attacks. And that led to this behavior-based Magecart mitigation approach that basically departs from the assumption that sooner or later your web application will be breached. There are simply too many ways in, considering the average number of dependencies that web applications have. So the approach becomes detecting and blocking a web skimmer at runtime. And the best approach for doing that is by monitoring the behavior of the code running inside the web application. So a web skimmer will always show signs of malicious activity. For example, if we see a live chat script running in a checkout page and accessing the payment form, then that's obviously a behavior that tells us that something is wrong. Or if we see a previously unseen script running in some or even all of our user sessions, that's certainly something that we'll want to investigate because it could potentially be a web skimmer. Or if we see data going out to an unknown domain, this might be a sign of potentially malicious activity. These are just a few basic examples, but I'll explore a couple of more advanced scenarios in a minute. Detecting is important, but even more important is the ability to block the malicious behavior. This is the only way to actually mitigate the web skimming attack. But for this to be effective, the blocking must be done in real time, regardless of the script that is showing that behavior or what browser and device is being used. It should also be granular because we want to be precise in blocking just the malicious behaviors. We don't want to block more than what we should. And finally, it should provide good actionable data for the incident response teams or for the SOC teams to understand where the attack came from and to do the final cleanup. Our solution, Web Page Integrity, is based on the principles that I've just presented. This solution puts a JavaScript agent in every user session, combines multiple detection and protecting techniques. We look for DOM changes, form hooking, code poisoning, suspicious network accesses, etc. It doesn't rely on detection signatures, but on detecting behaviors. So new forms of web skimming attacks are also detected. And finally, a very important aspect, it is the only solution in the market that includes resilient code protection, which makes the solution unique because it's the only one capable of defending itself from tampering attacks from the web skimmers. Now that I've covered how we handle detection, let's see how we block malicious activity. We use this strategy based on permission levels. So for the first level, we control whether or not a certain script is allowed to load or if it should be blocked. At the second level, we allow our customers to control the behaviors of scripts based on high-level assumptions about what they should do. And the third level, they have the finest grain of control of every tiny action that the script is performing. Let me give you some actual examples. For instance, as a user of Web Page Integrity, I would have the ability to block or alert if a script is installing an on-submit event handler, which is very typical of web skimming attacks. I could also block any type of connection that tries to send data out to a previously unknown domain, or if specific methods are used to send that data out, like WebSockets. Blocking any script that does anything to a specific payment form, so we can actually set which scripts are allowed to touch the payment form and which scripts aren't allowed to do that. And by combining some of these rules, we can get to a point where we have a very strict control of the behavior that we allow in our website without breaking things or compromising the user experience. Moving on, I'd like to take a couple of minutes to mention one of our most recent success stories, which is a major airline that came to us for mitigating Magecart, basically wanting to prevent becoming the next British Airways. So they wanted to know if any of their scripts changed behavior and to have the ability of blocking any web skimming attempts. They wanted this to have minimal impact on the performance, as that is directly tied to their revenues. And finally, they wanted the ability to send information to their CM. They implemented web page integrity successfully, using our behavior-based detection and behavior control to actively detect and mitigate any type of skimmer. And our approach passed all of their detection tests. They also use our inventory of scripts and network events to get a clear picture of their platform at any given time, and our dashboards allow them to quickly see any malicious behavior and where it comes from. We transitioned from a POC to a production environment without any hiccups, and they specifically mentioned the value of being able to easily integrate the solution with zero or minimal impact. So we covered a lot of ground today. Karen gave us a snapshot of the current state of web skimming attacks, which is showing clear signs of growth. These attacks are still a significant cost to affected companies, not just in fines, but also in reputation loss and therefore sales losses. But why does this still happen? Well, because companies have a security blind spot in regards to the client side. They don't really know what is happening there, what scripts are running, and this allows web skimmers to remain active for weeks. During that time, they can exfiltrate thousands and thousands of credit cards without companies or even end users being aware of the attack. So Karen also explained why approaches like CSP and SRI and others fall short when it comes to mitigating these web schemers, especially because they keep evolving their tactics and bypassing these protections. There are simply too many ways in for attackers to execute malicious code on the web applications. We have no other option than assuming that our web application will eventually be breached and malicious code will be executing inside of it. And when that happens, our best shot is to detect the attack in real time, not because we have a signature for the attack, but because we recognize the malicious behaviors and be able to block it. So we have delivered this behavior-based approach to a major airline and to major retailers who now have protection against Magecart with JScrambler web page integrity. Well, I think that is all from our side. I believe that now we still have time for some Q&A. So I'll hand the floor over to Philippe, who will go over your questions. Thank you.
Thank you, Pedro and Karin. So yeah, feel free to share the questions you may have here in the chat box. We'll still have some minutes to answer your questions. We'll go over these during these final 15 minutes or so. So feel free to let us know. All right. It seems that we have one question here from Isaias, who is asking, is this protection detects attacks in real time on JScrambler platform you can block? Pedro, I'll pass the floor over to you.
Thank you, Philippe. So yes, so this is all working in real time. And in order to have the ability of blocking, it needs to be in real time. So it's not only alerting, which we also do, but yes, we need to do this in real time. Otherwise, we wouldn't be able to block.
Great, Pedro. Thanks again. So I'll keep on reading the questions. It seems that we already have another one here. From Charlotte, who is asking, can you explain with more detail how your approach detects new attacks? Do you use any type of signatures? So again, Pedro, can you give your input here?
Yeah, actually an interesting question. If we were in fact using signatures, I mean code signatures, if we were looking at the aspect of the code and just rolling out signatures, the question makes all the sense in the world, because as the code changes, as the attacks change, so does the code. And it's really the problem that you have in a lot of antivirus products. But in our case, we don't use code signatures. What we use is behavior signatures. So actually, So let's say let's try to give an example. The code can have completely different look and feel, but if the underlying behavior is actually doing something that we consider to be malicious, then absolutely that will be picked up by our rules, by our behavior rules, and that applies to new attacks. Of course, if the new attacks are showing completely new behaviors that we didn't anticipate, then we can see it happen, but we may not have the rules to do some preset action on them. But as very quickly they will bump into our rules, because we basically look at different scripts and their actions by action categories. Like they can be dealing with the form, or dealing with cookies, or trying to send data out through the network. And we have precise compartmentalized rules for those types of actions that makes it very hard for any new attack not to hit one of those rules.
Perfect, Pedro. And so I will move on, because we have a follow-up question here from Isaias, who asked, also, this occurs on the browser side, so this feature could be tempered, blocked, modified. And he's asking if this feature is obfuscated to protect it. And I know that you can answer here, Pedro.
Philippe, you could even answer yourself, but I'll go ahead. Yes, of course. In the browser side, it's an adversarial space, which means that any code running alongside your code can potentially be targeting your own code, trying to tamper with it, trying to change the behavior of the script. And obviously, the code that does the behavior enforcing and alerting is also code, so can potentially also be tampered. So what we do in regards to that is, because we come from a background of code protection on the client side, of course, we apply every trick that we know, and we know a lot because we have been working in this area for 10 years now, to actually protect our code from tampering, and for any type of interference. Also, we use techniques that basically set the stage to make it harder for other scripts to actually try to mess with your own code, because we are loaded first, and we not only we are tamper resisting the code, but also we block some avenues of integrity attacks against our own code.
Okay, Isaias, I hope that this helps answer your question. And meanwhile, because we still have a couple, I would say a few more minutes until the end of the webinar, I'll still entertain more questions. I see that someone is already typing. So we'll just probably answer a couple more questions. And so starting with this one from Lucas, he asked, you mentioned you use a JavaScript agent to deploy your solution. How does that affect the website and the user experience, Pedro?
Yeah, so that's a good question, a somewhat common question that we have. Obviously, the solution is designed to be as least impactful in the page performance as we can, and obviously all of this only makes sense if we're not impacting too much the performance of the page. Also, there's the question of impact on the user experience. So we must be sure that we are not changing in any way the behavior of the page, other than blocking the malicious behaviors, of course. A few things that we do rely on techniques that we have used for quite a while, because we have been with the code integrity side of our technology. We basically, most of the things we do is rewriting JavaScript code, So we always have been very conscious about the impact that we impose when rewriting the JavaScript code. So that brought us a lot of experience in doing this, and obviously we employed all of that knowledge in designing what we do and how we are doing that in the behavior enforcing code. So basically, the short answer is it's very short impact on the perceived performance of the page, and we are successfully running in our clients with no complaints in that department.
Okay, thanks again, Pedro. Lucas, I hope that Pedro was able to answer your question clearly. And so I think meanwhile we don't have any incoming questions. So feel free. I think we still have a few more minutes. If no other questions arise, meanwhile, I'll obviously end the webinar, and I'll just give a couple minutes or so, or just a few seconds to see if everyone is satisfied. I think everyone was pretty satisfied with your answers, Pedro, which is always good to know.
I hope so.
So okay, I'll probably move on to our final slide here. So we of course, I believe everyone knew this. So after the webinar ends, you'll receive an email with our own info sheet on about this topic, about preventing Magecart attacks. And this will give you an in-depth explanation of what we discuss here today. And it's a document that you can just bring into your company and share with your team if needed. As I mentioned earlier, if you have any specific questions, and if you weren't able to place them here, feel free to reach out to us using the email you see here. And of course, in case you're interested in discussing the possibility of doing a POC, do send us an email as well, and we'll get back to you as soon as possible. And yeah, I believe that's it from me and from everyone here at JScrambler, Pedro, Karen. I hope that everyone else out there is staying safe. I look forward, of course, to seeing you in our next webinar. So thanks everyone for joining us, and bye for now.
Thank you.